Hi guys, I just wanted to solve one of our common base problems with you today. We talked about earlier in class that if the bases of a problem were equal, that meant the exponents were equal. So earlier in class we had an example like this, 2 to the x equals 2 to the fourth. And you guys were able to tell me that the value of x was equal to 4. Because if this term, 2 to the x, is equal to 2 to the fourth, we have equal bases. These are both 2's. So the only thing that's left to be equal with that equal sign would be the exponent. So x would be equal to 4. Now, problem 17 was different than that. Problem 17 had two different bases. So take a second to try and figure out what the bases are, and then play me when you're ready. I chose the base of 3 because 81 could be rewritten as 3 to the fourth power. And I still have that exponent, x cubed plus 2x squared. 27 is 3 to the third power, and I would still have that exponent of 5x over 3. So now if I'm going to solve, my bases are equal. I have a 3 in both sides of the equation for the base. What's left is a 4 times x cubed plus 2x squared on the left side, and a 3 times 5x over 3 on the right side. So to simplify, I'm going to distribute the 4x cubed plus 8x squared, and I'm going to multiply on the right side. 3 times 5x is 15x, and 1 times 3 is 3. So really what I'm looking at is 4x cubed plus 8x squared equals 5x. Now this question is a lot more involved than any of the other ones we did in class, and it actually would be worth 6 points. Up to here, you've done all the new material. You got a common base and you multiplied. After this point, this is stuff you mastered in the first month of school. Solving equations. Step 1 would be to set the equation equal to 0. Step 2 would be to start to solve, and in this case, look for factoring. I have a GCF of x. So if I divide each one of my terms by x, I'm left with 4x squared plus 8x minus 5, and all of that's equal to 0. Well, now I need to factor even more. You could use the quadratic formula here, if that's what you're comfortable doing. However, I'm going to review a little AC with you instead. You would get the same answer whether you use the quadratic formula or AC. So let's see what we got. The x is going to come down on the outside, and I'm going to do AC on the inside. I keep my first term and my last term. I am looking for what multiplies to 20 and subtracts, due to that last sign, to 8. That's going to be 10 and 2. Bring down the plus for the 10x. A positive times a negative is a negative for the 2x. And now I can factor by grouping. Take a GCF out of the first two terms and you're left with 2x plus 5. Take a GCF out of the second two terms, it's really just 1, and you're also left with 2x plus 5. I know it looks like 2x minus 5, but don't forget to distribute that negative sign. So now we know we're on the right path because both of these have a 2x plus 5 in common. And what's left is 2x and minus 1. Bringing down your x from before, you now have 3 terms. And if you solve, x equals 0, 2x plus 5 equals 0, and 2x minus 1 equals 0. If you solve this equation, you're going to get negative 5 halves. And if you solve this equation, you're going to get 1 half. So there are 3 solutions to this problem. That is a 6-pointer. It reviews everything exponents, all of your factoring, and lots of solving. If you have any questions other than that, please see me, and I'd be happy to help you in extra help.